Hello everyone, and happy World Rewilding Day. I wanted to do something special for today because I missed it the past few years, and rewilding means a lot to me. And like many people, one of the first stepping stones into rewilding, and the biggest part of rewilding for me, was wolf reintroduction. And that stuck with me a lot over the years and helped guide my interest in ecological restoration. I kind of just like wolves. He's not a wolf unless you count domestic husky shepherd crosses as a wolf, which I suppose you can. But regardless, I decided to do my master's thesis, my master's in Ecology and Environmental Management, in the hypothetical reintroduction of grey wolves into the Lake District National Park, the closest national park to me. So in the spirit of World Rewilding Day, please enjoy my master's thesis as narrated by myself, and hopefully by the time this is up, I have edited it to a satisfactory standard. Now I'm going to let my Canis, my little wolf, go catch this ball. Have a good day.
Returning Cumbria's Lost Canines, a feasibility study for the reintroductions of the wolf, Canis lupus, into the Lake District National Park. Written by Scott Anthony Pye, supervised by Reverend Paul Rooney. A dissertation submitted for the Masters of Science in Ecology and Environmental Management in Liverpool Hope University, in partial fulfillment of the regulations. Submitted October 2024. Abstract. It is a long-held belief among many that in order for a habitat to support an apex predator such as the grey wolf, Canis lupus, it must be well away from human settlement and influence. It is this belief that largely influences the idea that, of all of the countries that make up the UK, Scotland is the best place to begin their reintroduction if it is to ever take place at all, as this is the nation with the fewest human inhabitants per square kilometre, and most land that can be considered wild. But as is seen in the literature, recent natural recolonization by the wolf on the European mainland shows them to be very flexible in their habitat and prey requirements, shaking up long-held beliefs. And with this recolonization comes a whole slew of environmental benefits that could massively aid in ecosystem restoration at a landscape scale. These predators are now found in every mainland European country, including those more densely populated than England, such as Belgium and the Netherlands. This showcases the species' adaptability to the new wild landscapes of the modern age, and perhaps their ability to tolerate or even thrive within places where it was once unthinkable for them to even survive. This paper finds the fundamental requirements for wolves to make a living within the Lake District National Park landscape, utilizing and attempting to improve on methods found within other scientific literature. The study ultimately found that within the 2,362 square kilometer boundaries of the park, roughly 921.5 square kilometers is suitable for long-term inhabitation by Eurasian wolves, as enough prey and appropriate land cover away from dense human populations are available. With estimates based on reliable research of mainland Eurasian wolves and taking their adaptability into account, it is estimated that the park could support between 9 and 24 packs of 5 individuals if the average territory size falls between 35 and 100 square kilometers. The conclusion is reached that the reintroduction is not only feasible, but highly beneficial to the national park both economically and ecologically. Declaration. This work is original and has not been submitted previously in any support of any degree, qualification, or course. Signed, Scott Pye. Acknowledgements. A professional thank you to those working for the Copernicus Land Monitoring Service, National Biodiversity Network Atlas, Office for National Statistics, and the Ordnance Survey, whose work in recording data allowed for the creation of this model. I would also like to extend my gratitude to Gwyn and Simeonakis for developing the original methodology on which this entire study is aiming to expand upon and apply in different contexts. This work takes much inspiration and guidance from your original high-quality piece of literature, and I thank you for making it available. Thank you to Reverend Paul Rooney for assisting in guiding the course of this master's thesis throughout its development, and without whom its completion would not have been possible. Finally, I would like to showcase my appreciation to my family, friends, and colleagues for their continued support throughout my master's course, particularly Sandra Pye, Claire Rigby, Laura Christmas, and Matthew Darban. Aims and objectives. The primary aim of this research is to develop a rule-based feasibility model for the potential reintroduction of wolves into the Lake District National Park. This study seeks to assess what are the most important environmental and ecological factors wolves require to successfully inhabit the region into posterity. Number 1. Identify key factors. Using rationale supported by the literature, determine the most important ecological and environmental factors grey wolves need to survive and reproduce successfully in any given space. Number 2. Develop a rule-based feasibility model. Using the knowledge gained from current wolf research, design and create a model that integrates the key ecological and environmental factors to evaluate viable habitat available to wolves if they were to be reintroduced into the Lake District. Number 3. Determine the carrying capacity. After developing a feasibility model, use it to determine how many wolves and/or wolf packs could be supported by the Lake District National Park before they would need to disperse further afield. Literature review. Introduction. Wolves have long been associated with some of the world's most wild places, far from humanity within the depths of forests and similarly isolated habitats, largely thanks to folklore and fairy tales. But as many are beginning to see, the wolf is an incredibly adaptable generalist species that inhabits a wide range of habitat types, including some of which would previously have never been considered, such as agricultural land. On the European mainland, an astounding level of adaptability to environmental stresses has been observed, as seen in the Jarausch et al. 2021 research where wolves were seen living within forestry plantations and intensively managed agricultural spaces, despite persecution and deaths on roads being high. Within the UK, efforts to reintroduce the wolf to its former range are frequently suggested to begin within the Scottish Highlands, an area that is often regarded as one of the wildest landscapes left in Britain. The reasoning for their reintroduction to the UK can be seen within areas where the wolf has recovered from its extirpation across the world. There have been measurable ecological benefits to its return. The most notable of these is the reduction in ungulate densities and the implementation of the landscape of fear effect that native non-human apex predators exert upon their prey species, which lead to trophic cascades influencing the wider ecosystem, especially plant communities. But like all animals, the grey wolf requires habitat conducive to supporting its species' prolonged existence, meaning that before any reintroductions are to be considered, the ecosystem must be able to provide for their dietary, behavioral, and spatial needs. For wolves, a suitable prey base needs to be readily available, which in Europe is often made up of 1 or 2 locally preferred ungulate species, like red, Cervus elephas, and roe deer, Capreolus capreolus, in Europe, as well as enough room in which each pack can occupy safely without overlapping with one another, or bleeding into areas where their presence will not be tolerated by humans. Using the model developed in the Gwyn and Simeonakis 2022 study, and available literature on the topic, there will be an attempt to determine what key requirements are needed to support viable wolf populations in the context of ecological stability in a given area. And from this, a model will be developed that is applicable to our study location, as well as the wider British landscape. Why wolves? Much of the UK has unnaturally high densities of deer, particularly red, which exceed the natural carrying capacity of the ecosystem. The study conducted by Gwynn and Simeonakis found that in some areas these densities are as much as 150 individuals per square kilometre in the winter. This logically has a substantial negative influence on the natural regeneration of trees and other vegetation in these spaces, as the deer overgraze and overbrowse areas looking for food. Many studies identify the 1995 reintroduction of wolves to Yellowstone National Park in the United States showcases the tritrophic cascade that could possibly occur in the Scottish Highlands, as wildlife communities are of similar composition. Though it is important to note that unlike Yellowstone, Scotland lacks the presence of supporting apex predator communities, such as brown bear, Ursus arctos, and mountain lion, Puma concolor, which also assisted in elk predation, albeit to a lesser extent. The lack of brown bears and a similar niche felid such as the Eurasian lynx in the United Kingdom mean that the impact of wolf predation on red deer may not showcase itself in the exact same way as Yellowstone, and this factor should not be underestimated. Using calculations developed by Nielsen et al. 2007, the Gwynn and Simeonakis 2022 paper suggests that over a period of 60 years of wolves present in Scotland, red deer densities could decline to 7 individuals per square kilometre, reducing their populations by more than 50% in some areas. While studies by Dolpachev et al. 2022 and Rodriguez-Riccio et al. 2022 observe that wolves may change the abundance of ungulates, in their case roe deer and moose, Aseles, in an area through predation. The Randon et al. 2020 study found these effects are likely to be temporary, and eventually numbers hit a stable equilibrium. The implementation of the landscape of fear effect may prove to be even more influential on the environment's ungulates, among other prey species. The Chersky et al. 2021 study was able to clearly display that the mere presence of wolves within the Polish forest environment drastically changed the feeding habits of red deer, but also found that bison, a less utilized prey source, only changed marginally in response. Conversely, the Barger et al. 2008 paper found that Iberian wolves, Canis lupus signatus, had less of an influence upon their local red deer population, the most probable cause for this being predation was less likely on this species, in a similar manner to the bison of the Chersky et al. Study. These wolves did, however, increase the density of roe deer groups in response to their presence, which coincided with the frequency of predation on this species in the area, the density increase in this instance being a survival mechanism. Although human intervention is widely used to protect forests and vegetation communities, it is often regarded as ineffective due to the lack of observable long-term changes in deer feeding behavior, and how it usually relies on massive yearly population reductions or fencing, which is very costly. Despite human activity showing to be an influence in the space usage by deer species in the Bonnet et al. 2020 study, it also found that this was usually limited to daytime, whereas the influence exerted by wild predators such as lynx and wolves are less predictable for prey. The impact can be considered more consistent and reliable in their implementation of the landscape of fear effect than humans. Because of this influence on their prey, this often presents a compelling argument for wolf reintroduction, as current deer reduction efforts undertaken by the British government incur a hefty financial sum, which wolves could help mitigate the costs of. Wolves will also likely assist in regulating mesopredator populations through direct predation and exerting pressure onto their daily behaviors in a similar fashion to how coyote, Canis latrans, numbers dropped significantly after wolves were returned to Yellowstone. This would aid in releasing ground-nesting birds, small mammals, amphibians, and reptiles from the unnaturally high predation rates put on them by Britain's foxes, Vulpes vulpes, and badgers, Meles meles, which number around 430,000 and 485,000 respectively. Again, this would be taking much of the financial and cultural burden off of the government, as culling efforts are not only costly but highly controversial. There is also a non-negligible economic incentive to reintroduce these large predators to such a tourist hotspot, see Appendix 1, as research conducted by the World Wildlife Fund 2023 found that during 2012, around 50% of tourists in the Sierra de la Culebra region of Spain came specifically for wolf watching, resulting in a minimum expenditure of €440,000 for food and accommodation. Similarly, Banff National Park, Canada makes $6 billion from wildlife tourism, which includes wolf and other predator watching. Considerations for conflict. As with any species reintroduction effort, it is important to consider how those living with these animals are likely to be affected. Although this study is focused on the ecological feasibility of wolves using the Lake District National Park, an excellent and vital consideration the Gwynn and Simeonakis 2022 paper takes into account is the public acceptance of the species by rural communities that will have to live alongside this species if/when a reintroduction effort is undertaken. Public safety is a high concern from some individuals, as many perceive the wolf to be a potentially dangerous species. This is despite the fact that there have only been 26 fatal wolf attacks globally between 2002 and 2020, with the majority of attacks being contributed to rabies, a disease that is considered to be absent from Britain. Indeed, it would seem that the more realistic cause for conflict would arise from wolves attacking livestock, as opposed to human beings. As seen heavily in literature such as the Gao 2024 book, fear of livestock predation is by far the largest influence in preventing the return of the grey wolf to the United Kingdom. But as the Guimarães et al. 2022 study and other research shows, wolves tend to prefer to predate on wild ungulates over domestic livestock where the energetic cost of hunting domestics exceeds that of wild prey. This optimal prey theory is given more validity through much of the literature when taking into consideration the percentage of livestock that is taken in certain areas, which despite relative abundance of easy-to-capture domestics, was low. It seems that wolves living in areas where farmers offer a greater degree of protection, like in the form of livestock guardian dogs, choose to prey on domestic animals rarely, as they likely appear less energetically profitable. This was observed in the Octagnac et al. 2020 study, as only when livestock vastly outnumbered wild prey items to the point of the latter becoming scarce, did wolves have to rely on these, dogs, and smaller prey items to survive. Compensation schemes have proven to be quite effective at mitigating human-predator conflict around the world, but as is mentioned in the Monbiot 2013 book, streamlining the process of compensating farmers is vital in getting local communities, especially farmers, to accept predators' existence. In the Heidenpah et al. 2016 study, one can see that countries like Finland have tested predator tolerance grants, where livestock owners are paid an annual sum just to live alongside wolves, lynx, and other predators, regardless of whether they have suffered from depredation. Despite long-held animosity for wolves from farmers across the world, mindsets are changing, as even shepherds are learning to live with and appreciate these predators for the ecological benefits they provide. What are the key factors? To create a model to assess the suitability of a given habitat, one must first determine the key factors wolves would require to survive and thrive in the varied landscapes of Britain. As with all species, the wolf will have limitations to the extent in which they can utilize resources in each area, be it territory, food, or proximity to human settlements. Perhaps the most important factor for any species is the availability of food, And as can be seen in research such as the Mattioli et al. 2011 and Chertsky et al. 2021 studies, wolves are generalist predators capable of taking a wide range of species. While wolves are capable of utilizing more than a single prey source, they tend to favor one or two species. Yet there is some debate as to whether prey is selected primarily via abundance or efficiency. However, it does seem that evidence is mounting that they develop localized preferences for a particular ungulate species. The Lake District National Park is home to substantial populations of red, roe, sika, that's Cervus nippon, and fallow, dama dama, deer, with both red and sika being highly hybridized between one another. It is only logical that due to the abundance of these animals in the area, some combination of these would make up the prey base for reintroduced wolves. When determining what prey density requirements our wolves would need, it is important to consider the high variation, especially in regards to subspecies, body, and pack sizes, which will drastically influence profitability. Jedrzejewski et al. 2008 found an absence of wolves only after prey densities reached a low of 0.6 deer per square kilometer, whereas similar studies of wolves within Yellowstone showed a requirement of at least 4 elk per square kilometer. Though it is worth understanding that the Eurasian wolf, Canis lupus from the Jedrzejewski et al. 2008 research, gathers in much smaller packs on average than the northwestern wolves, Canis lupus occidentalis of Yellowstone, meaning that prey density requirements for the former will be scaled down by comparison. And as Eurasian wolves were the species previously found in Britain, they will likely be the only subspecies considered for reintroduction to the UK, thus meaning the lower prey density estimate is more applicable to our model. Currently, red deer densities alone in the UK reside at around 14 individuals per square kilometre in many areas of Scotland, which share many environmental factors to our focus location, well exceeding even the highest requirements for a wolf prey source. By grouping the data for prey species most likely to be taken together, i.e. roe and red, in some areas, one can develop a population density that is more inclusive and reflects real-world options. The next key factor to analyze is the suitability of habitats that wolves utilize in order to survive and/or thrive. As stated previously, wolves are highly adaptable to both prey and habitat requirements, being found throughout the northern hemisphere, parts of the equator, and some regions of the southern hemisphere before human-induced extirpations restricted their ranges. Although studies like the one carried out by Gwynn and Simeonakis find a heavy correlation between wolf presence and forest cover within Europe, there is bountiful evidence, such as the Jarushk et al. 2021 study, that this is not a strict habitat requirement, and is instead more correlated to the abundance of prey species, which often increases within forests, and lack of human-induced mortality. Today, Eurasian wolves inhabit the majority of terrestrial habitat types available within their ranges as long as prey is also available. These include forests, open wood pasture, tundra, coastal wetlands, river deltas, desert, scrub, montane heath, farmland, and other human-dominated landscapes. Indeed, it seems that wolves are not restricted much, if at all, by habitat type. The Roda et al. 2020 paper found that in their study area of the French Alps, the biggest factor driving habitat use was instead the availability of prey, which is reflected heavily within related literature. But other factors definitely play a key role across Europe, and perhaps understandably, the Cimati et al. 2021 study found that acceptance by local human populations ultimately determines the continued use of a habitat by large carnivores in any given region. Sandom et al. 2012 experimented with the idea of using fenced-in reserves similar in essence to the landscape-scale reserves of South Africa to circumvent this issue, as the animals would all be restricted in their ability to predate on domestic livestock. Livestock, particularly sheep, are especially vulnerable to predation by wolves, as unlike many nations around the world, predation mitigation methods such as shepherding and livestock guardian animals are not readily used in the UK, despite their widespread success. Because of this fact alone, any areas with high densities of livestock should be considered unfavorable as wolf habitat until preventative measures are widely adopted. The methodology used within Gwyn and Simeonakis' study states that wolf habitat must be considered at a landscape scale due to the massive size of packs' territory, which on average span between 100 and 200 kilometers squared, though this varies greatly across the world. The need for large territories is supported by the Johansson 2002 study, which found that packs within Scandinavia have territories between 1,056 to 1,259 square kilometers on average, though conversely, research by Meck and Boitani 2003 showed that North American wolf territories can be as small as 33 square kilometers in Minnesota, and as big as 6,272 kilometers in Alaska. Keeping in mind that prey availability seems to be the largest natural influencer of habitat usage in these spaces. Territories used by Eurasian wolves in the Jedrzejewski et al. 2007 study never dropped below 80 and 100 square kilometers, despite extreme abundance of prey. Despite this, more recent studies have found that wolf packs in Lower Saxony and the Netherlands have territories ranging from 35 to 100 square kilometers. The extreme variability of wolves' needs for territory space leaves it difficult to determine how many individual packs could occupy the Lake District, but does provide us with rough estimates that can be applied to future calculations. As humans become more tolerant toward wild predators, the wolf has been allowed to establish across much of its former range. Despite this, there is still a lot of danger posed to them from proximity to human-inhabited areas. A large variation of tolerance for human density in relation to wolf presence is found within the literature and is referenced in the Gwyn and Simeonakis 2022 paper, finding suitable habitat anywhere between a human density of 0.43 individuals per square kilometers to 36.7 individuals per square kilometer in some studies. But with wolves recently recolonizing a national park in the Netherlands, a nation with a human density of 512 individuals per square kilometers, there is a lot of room for consideration for this factor. According to the Office for National Statistics census of the area, the Lake District National Park has a population density of 17 individuals per square kilometer as of 2021, their most up-to-date dataset. This falls well within the lower estimated human density levels tolerated by wolves, and way further under the extreme levels tolerated by wolves found in the Netherlands. This is also much lower than the 181 individuals per square kilometer average human population density of urban areas of the Zani et al. 2023 study, which found wolves inhabiting areas of the Arno Valley on the outskirts of towns and cities. The study also suggests that whilst wolves prefer to keep a large distance between their territory and human settlements, intraspecific competition drives them to tolerate a closer proximity, which is supported well by the literature. This certainly demonstrates the massive capability of these animals to adapt and thrive within a human-dominated environment. Road density has been showcased to be one of the biggest human-induced mortality factors throughout literature, as these unnatural additions to the landscape cross much of the available habitat available to wildlife. It is interesting to note that whilst the Gwyn and Simeonakis 2022 research found a suitability tolerance of 0.2 kilometers per square kilometer to 0.5 kilometers per square kilometer within the literature, the Zani et al. 2023 study noted wolves inhabiting areas of Italy whose road networks have a density of 2.92 kilometers per square kilometer. Though it is important to remember that many of the roads assessed in the former research are based on European and American roads, which differ greatly to those used in the British countryside. These roads were also given the same level of tolerance, despite the different levels of danger each road presents. This generalizes too much, as quiet country roads and motorways will likely incur different behavioral responses from packs inhabiting the areas. Because of this, it is important to attempt to grade each of the roads individually, or to only consider main roads and motorways in the overall habitat suitability model, as these busy roads pose the highest threat to wildlife attempting to cross. The Zimmerman et al. 2014 paper found that some smaller pathways like gravel roads increase in usage by wolves during their reproductive period. The frequency of any road usage did decrease depending on the overall size and frequency of human use of the said road. Literature Review Conclusion. It is easy to see that while much research has been undertaken to better understand the ecological and environmental needs for the grey wolf across the world, its generalist nature and ability to adapt to an assortment of situations means it remains difficult to truly assess how they would react when reintroduced into our study location, as no other location where wolves are currently present accurately matches up to it perfectly. Despite this, it is also safe to infer that due to the species' adaptability, culminating data from those areas most ecologically, geologically, and anthropologically similar to the study location would allow for the most accurate results, within an acceptable window of error. Areas within Western Europe such as the Netherlands, Germany, Belgium, France, and the lower regions of Scandinavia provide us with the best locations for comparison, as the wolves found in these locations would have to adhere to the same factors and principles that would be found within the British Isles. By utilizing the methodologies and understanding the rationale behind the acquired datasets of studies undertaken within these places, one will hopefully be able to develop our own for use within our target location that may be later applied at a greater scale across the whole of the British Isles. Methodology. Study area. The Lake District is England's largest national park, encompassing an area of about 2,362 square kilometers of largely mountainous terrain, pot-marked by a number of glacial valleys and 16 major lakes, the latter of which gives the area its name. The strata making up the bedrock of the area is made from a mix of limestone and granite, which formed 320 and 400 million years ago respectively. Most of the landscape contains shallow acidic soils that are low in fertility with a scattering of blanket bog, all of which are vulnerable to erosion from low vegetation rates caused by overgrazing from sheep and deer. It is denuded of much of its natural vegetation communities through historical agricultural use, which currently takes up 55% of the park's land cover. Only 12% of the area within the national park contains woodland, almost half of which is agroforestry. Unlike areas at similar latitudes around the world, the Lake District has an average temperature of 3 degrees Celsius in winter to 15 degrees Celsius in summer, and with relatively low fells, snowfall is rare. The county in which the Lake District is situated is also said to be the location of where the last wolf in England was hunted, according to local folklore. This, along with local place names like Ulverston, which derives its name from the Norse and Old English meaning wolf army, are strong cultural connections to the species, which could prove useful in establishing acceptance should they be introduced once again. The southwestern reach of the Lake District extends onto the coastline of the Irish Sea, which contains coastal sand dunes, one of Britain's rarest habitat types. The Eskmeal dunes are grazed by cattle to prevent succession by grasses, which would be detrimental to the dune ecosystem. These provide vital habitat for an assortment of species of rare organisms. Most notably is the UK's most endangered amphibian, the natterjack toad, Epidalia calamita, which relies on the dune's temporary ponds to house their young during the spring. Although some argue that the lack of trees and other vegetation on the Lake District fells is attributed to them being above the tree line, the area in which trees are capable of growing, this doesn't hold up well to scrutiny. See Appendix 1, as most of the Lake District falls well within the elevation range for growth seen at similar or even colder latitudes, and contains an environment conducive to trees throughout much. Instead, much of the national park, like elsewhere in Britain, has been historically deforested for timber and agricultural use, which continues into the present day. Much of the private land is unnaturally maintained as moorland to help encourage the proliferation of just a handful of species, particularly red grouse, Lagopus scotia, which is shot en masse yearly. This restricts the natural regeneration of the landscape for use by a myriad of other wildlife species. In areas where allowed to persist, oak woodland creates a biodiverse understory where mosses, ferns, and other plants associated with Atlantic rainforest can thrive. Despite these shortcomings, the national park does contain an interesting assortment of species. In the small amount of woodland cover that is conducive to the species' continued existence in the region, the red squirrel, Sciurus vulgaris, can be found at some of the highest numbers in England. This may possibly be due to the persistence of pine martens, Martis martis, in the area, that have shown to preferably target the invasive grey squirrel, Sciurus carolinensis, limiting their impact on the native reds. Many wild roaming species of ungulates, such as deer and wild ponies, call the fells home, and are largely responsible for the overgrazing and overbrowsing seen in the area alongside domestic species. Until recently, the area enjoyed England's last breeding pair of golden eagles, Aquila chrysaetos, which are now thought to be extinct in the region. But other raptors such as the osprey, Pandion haliatus, are now successfully breeding in the area. Due to the abundance of lakes, and in turn fish, the Lake District has a healthy population of Eurasian otters, Lutra lutra, which feed on the high variety of aquatic species in the region. Although the UK is home to a total of 15 national parks, England containing 10 of them, it was determined that the Lake District would serve as an excellent pilot study for wolf reintroduction in England due to its proximity and superficially similar habitat to Scotland, the nation that receives the most attention for such feasibility research. One of the aims of this research is to develop a model that can be applied UK-wide, to assess the full range of space available to wolves should they be fully released back into the British mainland. Rationale and datasets. As wolves are a highly territorial species, a single pack will take up many square kilometers per home range. The exact number of this is not truly known. As one can see from the literature, these animals' territories can vary greatly, depending on the resources available, pack size, and proximity to human populations. Whilst many list the average territorial range for all wolf subspecies to be between 100 and 200 square kilometers, there is ample evidence to suggest that the average territory size is actually between 35 to 100 square kilometers for Eurasian wolves in prey-abundant, human-dominated landscapes. It is acknowledged that whether or not these parameters reflect what would actually occur should wolves be reintroduced to the park, they would not stay within its confines, as the species disperses over great distances to find new territories, and would likely follow the roving herds of prey into neighboring landscapes. Regardless, this should give a rough estimate for territory size that can be applied to the model and across different areas of the UK and beyond. Land cover. In terms of habitat types that are exploitable for wolves, there are very few that have little to no use to these animals due to their extremely adaptable nature. The most hospitable landscapes are simply areas that offer an abundance of prey away from livestock, and are a reasonable distance from dense urban human populations, unless tolerated at its outskirts. These can be densely wooded areas, as are found around Lake Windermere, or the sparsely vegetated open fells of the northeastern hills, both of which contain high densities of both red and roe deer. Due to the adaptability of the species, it stands to reason that the only areas that could be considered inhospitable to their survival would be open bodies of water, dense urban settlements, and pastures. as the latter two are zones where conflict with humans is the most likely to arise, should the wolves choose to inhabit them. Grazing pasture poses the biggest obstacle to wolves due to its abundance in the landscape and the overabundance of unprotected livestock that would serve as easy prey, leading to the predator's persecution. Using the Corrine land cover map and its inventory of habitat classifiers, habitat suitability grading was determined by creating an index and scoring each on a scale of 0 to 1, as was done in the Gwynn and Simonakis 2022 study, but grading each with a more up-to-date understanding of wolf habitat tolerance. Urban fabric, 0. Industrial areas, 0. Road and railway land, 0. Mineral extraction sites, 0. Green urban areas, 0.2. Sport and leisure facilities, 0.2. Non-irrigated arable land, 0.7. Pastures, 0. Agricultural land with natural vegetation, 0.7. Forest, 1. Natural grassland, 1. Heathland and moors, 1. Woodland scrub, 1. Bare rock, 0.6. Sparsely vegetated areas, 0.8. Inland marshes, 0.5. Salt marshes, 0.4. Peat bogs, 0.8. Intertidal flats, 0.4. Water bodies, 0. In this index, areas were graded from 0, which is unsuitable for wolf inhabitation, to 1, which is ideal for wolf habitat. Areas conducive to large-scale roaming of animals such as forests, scrub, open grassland, and moors were scored favorably, as these spaces provide area to hunt and den in as close to a natural context as possible within the region. In contrary to other literature, arable farmland was scored highly, as wolves do not pose a threat to crops and may be drawn to these locations by roaming deer and other herbivores, inadvertently lowering crop damage. Peat bogs and other sparsely vegetated areas also scored fairly well, as they provide hunting grounds with open spaces in which to sight potential prey over large distances, though offer little to no value for denning. Although wolves have been shown to follow prey into shallow water in many areas of the world, deeper water is generally avoided due to the risk of becoming waterlogged during the colder months and succumbing to hypothermia. Because of this, the wetlands aren't as highly rated. Though it is worth noting that some wolves in Scandinavian regions utilize water bodies seasonally to hunt prey, which could possibly be seen in British reintroduced wolves. Due to the vagueness around what constitutes sport and leisure areas and green urban areas, there is a lot of possible habitat types this could refer to, some of which being physically usable by wolves but could pose a threat to their safety due to the proximity to humans, thus being quite low rated. Prey density. Deer occur at extremely high densities throughout the Lake District according to official sources, and the population of red deer in the region are some of the highest in the country. The same goes for roe deer, which can be found at an even greater density, particularly in areas of high vegetation cover. Other non-native species also occur within the region, but at much lower densities, though it is worth noting that the Sika deer in the region readily hybridize with reds, which has resulted in fertile hybrids. Despite their occurrence in the region, maps were only created using red and roe deer, as they would be the most reliable food source for grey wolves. Maps for deer densities were created in the program QGIS at a resolution of 1 km squared, with count data attached to each one, with a kernel radius of 4.5 km squared. It should be noted that pilot point data was obtained from the NBN Atlas and represent singular sightings of one or more animals from different points in time, meaning that many of the different points could be showcasing the same individuals just in a different location and aren't truly indicative of population density alone. But these plot points and their reoccurrence can be used to infer the usage of these spaces by the species. Obtaining exact population estimates for red and roe deer specifically for the Lake District National Park proved to be difficult, as no official reports conducted in the area give out these numbers. Despite this fact, one can cross-reference this information with widely accepted population national density data, like that from the Forestry Commission and comparable locations in neighbouring parts of Scotland, to create an accurate population density map. With this information, density maps have been created with a conservative average population density estimate of around 10 to 15 individuals per square kilometre for red deer and 25 to 30 individuals per square kilometre for roe deer, both well above the minimum prey density range for Eurasian wolves. Human density. Data for human density was obtained from the Office for National Statistics census and applied within the Lake District National Park boundary. Within QGIS, data at the Lower Super Output Area (LSOA's) level was applied to each area on a vector map of the park in which smaller urban areas had the highest concentrated population, whereas the opposite is true for more rural areas, where the populations are more widespread. Some of the LSAO's boundaries reach noticeably outside those of the national park itself, but effects of this on the study seemed negligible. Road density. Data for road density was obtained from the Ordnance Survey Open Roads data map. This vector map was applied to QGIS to showcase density per square kilometre. Originally, this study aimed to separate each road type into different levels of tolerance, but due to the constraints of this master's study, this was unachievable. It is also worth mentioning that while studies conducted within the United States and mainland Europe are widely referenced in regards to wolf road tolerance, British roads differ greatly in both size and traffic types than in other parts of the world, especially when it comes to country lanes. Because of this, road density remains the weakest of the four determining variables. Results. Our generated land cover map shows vast swaths of habitat as deep red, which indicated high level of suitability. One can see that the combined habitats of natural grassland, forest, peatland, moors, and sparsely vegetated areas create extremely well interconnected wolf habitat that led into mid-tier areas such as bare rock in more mountainous regions. Much of these border agricultural cropland that in previous studies would act as a barrier, whereas here is accepted as highly tolerable wolf habitat that nicely connects the prime natural habitats. Much pastoral land where livestock is grazed also borders or completely surrounds many square kilometers of prime wolf habitat, isolating a few areas. Interestingly, in their population density map, red deer, the assumed to be main prey source for reintroduced Eurasian wolves, occur in the highest densities throughout both highly suitable areas in the northeastern range of the national park, but also in the much more fragmented habitats in the southeastern stretches of the park. Though much of these overlap with pasture land, it appears the highest densities of red deer in the region still occur in prime wolf habitat, with the exception to the most southeastern point of the distribution map that borders RSPB Leighton Moss. There is also a strange record absence of the species within central western regions of the map, despite the abundance of similar habitat. While roe deer occur in some of the same habitats as red deer in their density map, some of their highest densities seem to occur in unsuitable areas such as pasture land, contrary to their reputation as a woodland species. Their southerly and central distribution around Lake Windermere, however, seems to coincide heavily with the abundance of woodland cover, though their populations still bleed out into neighboring pastures. Perhaps unsurprisingly, human density and road density were almost identical in their weighted distribution throughout the Lake District, as one is heavily tied to the other. While human density varies drastically throughout the research area, human population hotspots are highly concentrated within towns and villages, the most notable of which being Ambleside, Kendal, and Keswick. It can be seen from both the human density and road density maps that while there are large areas in between human settlements that remain at tolerable suitability levels, much of the area to the southeastern portion of the park contains too dense a human population for wolves to successfully thrive within the acceptable density levels. Even when keeping in mind that road density is still the weakest of all 4 variables. Overlaying all of these key variables together within QGIS lets us see the overall suitable areas where wolves can survive within the Lake District. The total area of best available space found within the park's boundaries amounts to around 921.5 kilometers squared, 39% of the park. Highlighted in green, see Figure 8. As can be seen by this map, there is extensive fragmentation between suitable habitats, most of which is divided by pasture land where livestock is grazed, or lakes. Though some of these areas that are not considered usable due to lack of recorded sighting of red and roe deer, and thus a prey base for wolves, much of the area otherwise meets other key requirements. With this calculation of potential available habitat, one can use the widely recognized average pack size, 5 individuals, and observable territory size, 35 to 100 kilometers squared, of Eurasian grey wolves living in similar habitats. One can estimate that the Lake District would be capable of supporting between 9 to 26 packs of around 5 wolves each, 45 to 130 animals in total. Discussion. The results have displayed a high level of convergence between all 4 of the variables, human density and road density being the 2 to line up near identically throughout the entire map. This makes sense, as although there are people living throughout the Lake District, the highest concentrations are within towns and villages, where the highest number of residents occur, and in turn, streets and roads can be found to accommodate them. Around the southeastern quarter of the national park, these also line up surprisingly well with high roe and red deer population densities, as well as the highest concentration of unsuitable pasture land cover. Outside of these places are large but scattered areas of highly suitable habitat, amounting to roughly 39% for wolves throughout the remaining 3/4 of the park, though some of these are divided by lakes, pockets of grazing pasture, or high human density. It is worth noting that although not listed as perfect wolf habitat due to lack of apparent prey species in the region, there is still suitable land cover within most of the park that is not displayed in Figure 8. Though not suitable for permanent inhabitation, these spaces can easily act as bridges between suitable hunting locations. Thus, the displayed suitable habitat is not entirely indicative of total pack territories. It is interesting to observe that in areas where human habitation or visitation is high, i.e. villages like Ambleside or tourist hotspots such as the lakes themselves, this is where one could see the highest number of deer presence within the NBN datasets, whereas there is much less presence recorded further away. There is a high likelihood of convenience bias present within the recordings, meaning that presence is recorded with higher intensity in these locations only because it is where observers are more likely to visit, whereas less popular destinations with lower visitor numbers may still have a high population of roe and red deer in the area, but observers are less likely to encounter them and record their presence. This is likely to be the case around Ennerdale Water, an area that is highly suitable habitat for both species of native deer, yet contains sparse presence recordings. Indeed, ground-proving this theory was undertaken by speaking to a ranger from the Forestry Commission when visiting the site, who confirmed the presence of both species and that their numbers were high enough on the plantation to merit annual culls. Due to the nature of the NBN Atlas's recording methods, including point samples in the same locations over different time spans, there is a significant margin of error, though this was accounted for by using available data for nearby deer populations. It may also be significant to note that during this dissertation, it was found that specific population numbers for deer within the Lake District National Park were not available to the public, and that the National Park Authority outsources this task to hunting estates, such as the Lonsdale Estates, acting under the North Lakes Red Deer Group, that have vested interest in keeping the populations unnaturally high. This is theorized as being linked to generating additional income by facilitating ease of access to game, which is a common problem throughout the UK in areas where the sport is ingrained in local gamekeepers. Despite what is actually recorded or presented to the public, one can see from available data that average deer population density, 10 to 15 kilometers squared for red and 20 to 30 kilometers for roe, far exceeds even the minimum prey requirements to support wolves throughout the majority of the national park. While the Corrine land cover's designation of certain land use types proved extremely useful for categorizing habitats, it must be acknowledged that there is much room for error and scrutiny of the habitat's classification, particularly with its classification of natural grassland, which from an ecological standpoint is arguably not wholly natural due to the centuries of overgrazing by native and non-native herbivores. Although this is irrelevant to its usability by wolves, it does display the evidence of shifting baseline syndrome present within the classification system, which could prove significant. There is also the problem of classifying agricultural land with significant natural vegetation, which is very vague with what it means by agriculture, which can refer to both livestock and crops. While the latter can coexist with wolves with little to no conflict, the former would require extreme changes to management for wolves to use these spaces with any regularity, which is unlikely to occur over a widespread area with current farming culture in the British Isles. Because of this ambiguous classification, it would be logical to further subdivide this category into livestock or crop landscapes in future studies. Further investigation showed that within the boundary of the park, this classification referred to cropland exclusively. The original method was developed in the Gwynn and Simeonakis 2022 study on the entirety of Scotland and tweaked using up-to-date information and reasoning in regards to wolf behavior, particularly with regards to Eurasian wolf recolonization, as well as the acknowledgement that there is still room for improvements in regards to grading of UK roads, which was not attempted due to the limitations of this study. One way this could be done is by creating a grading index system, similar to that which was used to grade different habitat types on a scale of 0 to 1, depending on their level of suitability. 0 being the most dangerous and thus unsuitable, and 1 being the safest and most tolerable. See Table 1. Although the methodology used in this project was only conducted at the scale of a national park, it can easily be applied to the wider UK landscape. Overall, the narrowing down to 3 key factors for wolf inhabitation was vital in the creation of this study: prey density, habitat type, and human density, with roe density in the UK being almost identical and thus possibly redundant as an entirely separate factor. It is worth noting, however, that proximity to high human densities can change with the level of cultural acceptance of the people living in the region the wolves are inhabiting, which can range drastically depending on a number of factors. For instance, while some individuals within mainland Europe go as far as killing the animals and using their heads as political statements, others, including traditional shepherds and farmers, tolerate wolves coming onto their land as they provide protection from wild boar and deer which can damage their crops. When considering the reintroduction of wolves to the UK, the greatest challenge is not ecological fitness, which has previously been noted as viable, but that of human acceptance. When creating a grading criterion for habitat suitability, human-dominated areas and livestock spaces were initially graded as unsuitable habitat, despite wolves being physically capable of inhabiting many of them. This was largely down to the danger posed by vehicles when crossing roads and the negative reputation wolves have within these places, which can lead to their persecution. This is especially true within farmland where livestock can become easy prey to wolves, particularly in the UK where fencing is very minimal and traditional shepherding is close to non-existent. It has been observed throughout much of the literature that in farmland where livestock protection measures are adopted, predators such as wolves, lynx, and brown bear rarely predate upon them. This is because prey selection in wolves is heavily agreed by experts to be determined by energy profitability, optimal prey theory, meaning animals that require more work to either take down or gain access to are less sought after. As the wolf continues to reestablish populations across Europe, ungulates that have gone multiple generations without encountering such a predator may become naive and easier targets, making them more profitable than well-protected livestock. This is validated in much of the literature when taking into consideration the percentage of livestock that was depredated in places, which, despite relative abundance of easy-to-capture domestics, was low. It seems that wolves living in areas where farmers offer a greater degree of protection, like in the form of livestock guardian dogs and shepherds, choose to prey on domestic animals only rarely, as they likely appear less energetically profitable. Although evidence of the wolf's top-down trophic influence over its environment is widely abundant within scientific literature, being observed even as early as the 1940s by Aldo Leopold, when he perceived the degradation of vegetation communities after ungulate populations became overabundant, there are obstacles that may prevent the full realization of this niche. Some studies have observed a dulled response to wolves in prey species in certain circumstances, especially in areas where wolves actively avoid human persecution. In these spaces, it appears that the landscape of fear effect usually implemented by wolves upon their prey species is negated, at least to some extent, by the wolf's avoidance of humans, leading to some areas of safe haven for ungulates to inhabit, and thus overexploit. These can be activities such as forestry, which do not directly harm wolves, but may cause avoidance for some time, but also include direct persecution such as predator hunting. To ensure that these animals would be free to express their full range of positive influence on the ecosystems they inhabit, it would be highly advisable to implement wildlife corridors and human exclusion areas, which are successfully utilized globally. It would also be majorly important to heavily enforce penalties, such as fines and prison time, for the unsanctioned dispatching or harming of wolves upon their return, which includes a strict no-hunting policy, meaning that should an animal become hazardous to public safety, only licensed officials would be allowed to cull them, a method that prevents wolves becoming habitually avoidant of certain areas where their impact is needed. The implementation of carnivore cohabitation tactics would require massive investments from both non-governmental organizations and the government to see any success among the wider farming community, which has a disproportionate level of control over the countryside. Predator-friendly farming labels are applied to specific products exported from North American farms that have adopted the practices and have been certified by the Wildlife Friendly Enterprising Network, WFEN, to ensure farmers have not negatively impacted wild predators in the product's creation. But if these methods were adopted by local farmers, it is safe to assume that there would be a greater degree of habitat available to wolves, as acceptance by local people would lower the risk of persecution. Acceptance of potentially dangerous wildlife by humans is sometimes considered by many to be unachievable in a landscape where they have been mostly absent for generations, though this can usually be blamed on cultural interpretation of the species, instead of actual risk. Though this can also be blamed on shifting baseline syndrome, as no one living in the UK has ever seen a wild British wolf, and thus cannot accurately understand living with them, unless they have spent some time living abroad. Cultural influences of the wolf can be seen not just within negatively associated fairy tales, but also within folklore and place names that provide a strong positive connection to the species, like the Wolva, a benevolent werewolf-like figure in Scottish mythology that provides fish for poor, hungry families. Alternatively, in many places around the world, these animals are an irreplaceable source of income, like in the town of Banff, Canada. Here they not only accept wolves, bears, and other large animals as an everyday reality of life, They celebrate them as vital parts of their landscape and a draw for tourism, which contributes an estimated $6 billion to the Canadian economy, one of many successful nature-based economies worldwide. If this level of acceptance was adopted by the Lake District National Park, it would be vital for the wolf's continued existence within the country, as over time the population would quickly outgrow the confines of this national park. And it is likely that even before the carrying capacity of the park itself is met, dispersing animals would find their way into neighboring land that is ecologically suitable to their needs, such as the Yorkshire Dales National Park, and there are no physical barriers to prevent them leaving. To maintain genetic diversity within the population, this dispersal would eventually become a necessity. If wolves are to be reintroduced to the park, advisable release sites would be within the largest, most undisrupted space available, possibly at the RSPB Haweswater Reserve that sits within the northeastern range of the suitability map, where red deer and dispersal opportunities are most abundant. Alternatively, Wild Ennerdale, a forestry commission site within the northwestern area, would also serve this purpose, providing benefits to the business directly by reducing deer grazing. Assuming that wolves would be allowed to fully realize their apex predatory niche, over time one would expect to see a dramatic shift in the habits of all species of ungulate within the park, as well as mesopredators that have redeveloped predator avoidance behaviors. This would result in more dynamic habitats, complete with more diverse vegetation communities, as well as biodiverse ecosystems, including the redevelopment of woodland and scrubland that were being held back by overgrazing and browsing, which in turn would aid in the prevention of soil erosion and flooding further into the lowlands. Species that were being suppressed by the overabundance of foxes and badgers would begin to increase in abundance, such as hedgehogs, lagomorphs, reptiles, and ground-nesting birds. With bountiful prey and carcasses left over from wolves, birds of prey like eagles would likely spread back into England from neighbouring Scotland, using the newly abundant tree cover for their eyries. This would be extremely helpful in reaching the UK's carbon sequestration and biodiversity net gain targets set out during the COP events, that they are currently not on course to meet before the original deadlines. Even without factoring in the other organizations' contribution or the benefits to other projects such as habitat restoration affected by deer grazing, one would expect the Lake District National Park Authority to save a minimum of £51,000 on deer culling annually alone. With a reinvigorated environment and higher abundance of wildlife, the national park would experience a tourism explosion, creating the opportunity for many new jobs centered around nature, particularly wolf watching, which is a big draw in mainland Europe and the Americas, with the Greater Yellowstone area making around $47 million a year from wolf watching alone. As wolves continue to recolonize across the world, it is only a matter of time before another island nation that faces similar ecological upheaval that have also extirpated their wolves, such as Japan or Ireland, decides to reintroduce these vital apex predators to their shores. Once this happens, it will not take long for the positive benefits of such a species in an environment similar to Britain to be seen, likely leading the other nations to follow suit in their own restoration efforts. If the United Kingdom is ever to be taken seriously on the world stage in regards to environmental matters, work to prepare for the return of keystone species such as the grey wolf must be undertaken, as only once all major ecological players are in place will one see widespread improvement in the land and its biodiversity. Future research on the topic should look further into the direct benefits to humans, such as disease and pest control that wolves provide. Determining the most effective methods of predator-livestock coexistence would prove invaluable, as wolves continue to prove themselves highly adaptable and will have no issue surviving and thriving in the British landscape otherwise. Conclusion. This study aimed to determine how suitable the Lake District National Park would be to the reintroduction of the once native grey wolf, and from there calculate the overall carrying capacity of the area. Using the literature to justify our reasoning, the variables were narrowed down to 4 key factors, land cover type, prey density, human density, and road density, with the latter two ultimately proving to have negligible differences. All were mapped in QGIS using data from reliable sources to showcase the level of suitability of each factor across the park, then overlaid to determine the park's overall suitability for wolf habitation. 921.5 kilometers squared of suitable habitat was found within the park. Much of this was divided by pasture grazing land or high human inhabitation, which would prove challenging to circumvent should wolves return to the area. Though a large portion of space deemed unsuitable was only labeled as such due to the apparent lack of prey in the area, it would otherwise be deemed usable for wolves traveling between prey sites. From the results gathered, a carrying capacity of between 9 to 26 packs of 5 wolves in the most favorable of estimates was determined. Should such reintroduction take place, it would require a substantial amount of investment into predator coexistent tools and methodology in order to be successful. But it was determined that the large ecological and financial benefits to the wider national park would make the expense worthwhile. This has been an unabridged reading of a dissertation written by Scott Anthony Pye and submitted as his thesis at Liverpool Hope University.